Pre-statistics. Using elimination to solve systems, Part 3. Lesson objectives. Use elimination to solve systems of linear equations. Compare 3 ways to solve a system. Lesson objective. Consider the system x plus 2y equals 4, y equals 3x minus 5. Number 1. Use substitution to solve the system. Number 2. Use elimination to solve the system. Number 3. Solve the system by graphing the equations by hand. Number 4. Compare your results from problems 1, 2, and 3. So number 1, we are going to solve this system by substitution. So if you recall, the first step in substitution is we look for an equation that has x or y isolated. So if we look at the second equation, we have y equals 3x minus 5. So the y is isolated. So we go to the other equation, and everywhere we see a y, we substitute the expression 3x minus 5. This will give us an equation with only one variable. So here we have an equation, 2 variables, x and y. We can't solve it, but we know that y is the same thing as 3x minus 5. So we substitute 3x minus 5 for y. Using the distributive property, we have 6x minus 10. Bring down our x. Bring down the equal sign. Bring down the 4. Combine like terms. This becomes 7x minus 10 equals 4. Add 10 to both sides. We have 7x equals 14. And dividing by 7, we see that x is equal to 2. We can use either equation. I'm going to use the second equation. And everywhere we see an x, we're going to substitute 2. So y becomes 3 times our x minus 5. Multiplying, we see that this is 6 minus 5. So the end result, y is equal to 1. So the solution to this system is 2, 1. Number 2. To solve this by elimination, we first have to line up the x terms, the y terms, the equal sign, and the constants. So I'm going to take the second equation, and I'm going to write it in the form x, y, equal sign, and number. So that means I need to subtract 3x to both sides. So I'm going to get a negative 3x plus y equals negative 5. Using my other equation, I have x plus 2y equals 4. And what we want to do is we want to eliminate either the x or the y. I'm going to eliminate the x. So that means I need to multiply this equation by 3. So this is going to become 3x plus 6y equals 12. So we have 3x plus 6y equals 12. And the first equation, which is negative 3x plus y equals negative 5, we add these two equations up. The x terms cancel. 6y plus 1y is 7y equals 12 plus a negative 5 is a positive 7. Dividing by 7, we see that y is equal to 1. To get x, we take one of the original equations. I'm going to take the first one, x plus 2y, and y is equal to 1. That equals 4. So we have x plus 2 equals 4, and subtracting 2 to both sides, we see that x is equal to 2. So the solution is 2, 1. This is the same answer as we got in problem 1. To graph this by hand, we first have to write this equation in y equals mx plus b form. So we have to subtract x to both sides. That's going to give us 2y equals a negative x plus 4. Dividing by 2, we have y equals negative 1 over 2x plus 4 divided by 2, which is 2. The other equation is in the form 3x minus 5. It's in y equals mx plus b form. To graph this, we go to a positive 2. That's the y-intercept. And we have a slope of negative 1/2. So I rise a negative 1 and run 2. Down 1 over 1, 2. Put our arrows. For the second equation, the y-intercept's negative 5. And our slope's a positive 3. So it means I rise 3. 1, 2, 3 over 1. Rise 3. 1, 2, 3 over 1. Connecting the points, we see the point of intersection is here. So the solution is 2, 1. So the answer to question 1, 2, and 3 is the same order pair. Using the graphing calculator, we put in the equation negative 1/2 x plus 2 and y1 and 3x minus 5 and y2. We hit graph. We can see point of intersection here, and if we hit second and trace and number 5 for intersect, we can see that the graphing calculator tells us the point of intersection is at 2, 1. If we use our table, we can see when x is 2, y1 and y2 are the same value, 1. Solving a system of two equations. Property: any linear system of two equations can be solved by graphing, substitution, or elimination. All three methods will give the same result. So let's summarize. So when's the best time to use graphing? If you want to estimate the solution, since graphing usually does not produce an exact solution. Substitution. The best time to use substitution is when one of the variables in either equation has a coefficient of 1 or negative 1. Elimination. If one of the variables have opposite or the same coefficients in the two equations. And using technology when the coefficients are large numbers so that the other methods may be cumbersome. Thanks for watching.